Hey guys, welcome to the channel. This episode is a recap video of some of the main ideas that you encounter in the chapter Motion Along a Straight Line. So let's begin. The very first idea is that of position. Now, the position x of a particle on an x-axis locates the particle with respect to the origin. So for example, if we say that the position of this car is x equals 3 meters, what we mean is that this car is 3 meters away from the origin. The origin is nothing but the 0 point of the axis. Now, the position of a particle can either be positive or negative depending on which side of the origin the particle is on. Suppose say we have a particle A on this side of the x-axis. Then the position of the particle A is positive. Say x equals plus 5 meters. On the other hand, this particle B over here is on the other side of the x-axis. So its position is negative. In fact, if you look at the line, we can say that x equals minus 3 meters. The next big idea is that of displacement. The displacement delta x of the particle is the change in its position. So delta x is equal to x2 minus x1. This equation calculates the displacement of an object. Now tell me this, can the displacement of a particle be negative? What do you think? Yes. If x1 is greater in magnitude than x2, then clearly this quantity delta x is negative. So what this means is that the displacement has occurred in the negative direction of the x-axis. Another important point about displacement is that it is a vector quantity. It is not a scalar quantity. The position of a particle, on the other hand, is a scalar quantity. Let's do a quick check. Here are two pairs of initial and final positions respectively along the x-axis. Which pair among these gives a negative displacement? The first pair is A minus 3 meter and plus 5 meters, and the second pair is B minus 3 meter and 7 meter. Now, in the first pair, the initial position is minus 3 meter and the final position is plus 5 meter. So the displacement is 5 minus of minus 3, right? So this is nothing but 8 meters. This is a positive displacement. Now in the second pair, the initial position is minus 3 meters and the final position is minus 7 meter. So the displacement here is minus 7 minus of minus 3. This is minus 7 plus 3, which is minus 4 meters. As you can see, this is negative displacement. Clear? If you have any doubts, drop a comment below and we will sort it out. The next big idea we encounter in this chapter is that of average velocity. So when a particle has moved from a position x1 to another position x2 during a time interval delta t, which is t2 minus t1, its average velocity during that time interval is given by V average, VAVG. Here the AVG stands for average. So V average is equal to delta x divided by delta t. This is nothing but x2 minus x1 divided by t2 minus t1. Now look at the numerator here. It is actually the displacement, right? So naturally, the average velocity is also a vector quantity, just like the displacement. The algebraic sign of average velocity indicates the direction of motion. If V average is positive, that's because the displacement delta x is positive, which means the particle is moving in the positive direction of the x-axis. Similarly, if V average is negative, that's because the displacement delta x is negative, which means the particle is moving in the negative direction of the x-axis. An important point over here is that the average velocity does not depend on the actual distance a particle moves, but instead it only depends on its initial and final position. So if you have a particle that starts at x equals 3, and it goes all the way to x equals 10 and then comes back to its final position to x equals 3 again, then the average velocity of this particle is simply 0, even though the particle clearly has traveled a non-zero distance. This is because the initial position and the final position of the particle happens to be the same. Another important point regarding the average velocity is that on the graph of x versus t, the average velocity for a time interval delta t is the slope of the straight line connecting the points on the curve that represent the ends of the interval. So as you can see in this graph, the time interval delta t is from here to here. The particle has moved from a position x1 to a position x2. This curve x of t gives us the position of the particle at each instant of time. The slope of this line is x2 minus x1 divided by t2 minus t1. And this is nothing but the slope, which is nothing but the average velocity. Clear? Just like average velocity, we also have the average speed. The average speed SAVG of a particle during a time interval delta t depends on the total distance the particle moves in that time interval. So AVG is equal to total distance in the numerator divided by delta t in the denominator. So this is pretty straightforward. There is nothing much to it. The only point is that the average speed is a scalar quantity as opposed to average velocity, which was a vector quantity. The average speed does not tell you the speed at this particular instant. As the name suggests, it tells us the average speed over a given time interval. So till now, we have recapped 4 main ideas. They are the position, displacement, average velocity, and average speed. Now, let us solve a simple problem based on these ideas. So, the problem at hand is the following. Imagine you are driving a truck along a straight road for 8.4 km at 70 km per hour. At which point the truck runs out of petrol and it stops. Over the next 30 minutes, you walk another 2 km farther along the road to the next petrol station. A. What is your overall displacement from the beginning of your drive to your arrival at the station? B. What is the time interval delta t from the beginning of your drive to your arrival at the petrol station? C. What is your average velocity from the beginning of your drive to your arrival at the station? Find it both numerically and graphically. D. Suppose that you buy the petrol, pay for it, and walk back to the truck. Takes you roughly another 45 minutes. So then what is your average speed from the beginning of your drive to your return to the truck? So I am going to leave this question on the screen. You guys can pause the video and try solving this question. This is a 4-part question. Let's solve each part one by one. So part A. This is asking for the overall displacement. So let's assume that your motion is along the positive direction of the x-axis. Your initial position is x1, which is 0. And the final position x2 is at the petrol station. So this distance from the origin to the truck is 8.4 kilometers. And this distance, that is the distance you walked, is 2 kilometers. So x2, the value of x2 is 8.4 plus 2, which is 10.4 kilometers, right? Now, the displacement delta x is simply x2 minus x1, which is 10.4 minus 0, which happens to be 10.4 kilometers. Now, part B is asking the time interval delta t. So we already know the time interval walking. Delta t walking is 30 minutes, which is 0.5 hours. What we do not know is the time interval of the drive. So delta t dr is the unknown quantity. However, we know that for the drive, the displacement is 8.4 kilometers and the average velocity for the drive, that is V average dr, is 70 kilometers per hour. So the time interval for the drive is delta x dr divided by V average dr. This is nothing but the average velocity formula, but we have rearranged a bit so that we can calculate the time interval. So the delta t dr is 8.4 divided by 70, and this is 0.12 hours. Correct? So the total time interval delta t is nothing but delta t walking plus delta t driving, and this is 0.5 plus 0.12, which is 0.62 hours. So we have found the total time interval delta t, which is 0.62 hours. Clear? Now in part C, we are asked to calculate the average velocity from the beginning of the drive to the arrival at the petrol station. Now this is really simple. We will use the formula for the average velocity. This is equal to delta x divided by delta t, which is 10.6 divided by 0.62 hours. Right? Remember this was the time taken for the entire trip, which is driving plus walking, the time for driving plus walking. So the average velocity, if you calculate, you will get 16.8 kilometers per hour. So this is the average velocity. Now let's look at the situation graphically. So this here is the position time graph. In the first part of the journey, you were driving for 0.12 hours and you traveled 8.4 kilometers. So this line from here to here indicates the driving part, right? Now, in the second part of the journey, you walked to the station for 0.50 hours and you traveled 2 kilometers. So this line from here to here indicates the walking part. So this is the initial position and this is the final point. If we join these 2 points, we get a straight line, right? And the slope of this straight line gives us the average velocity. So the slope is equal to rise divided by the run. The rise over here is delta x, which is 10.4, that is this part over here, and the run is delta t, which is 0.62 hours, and that is this part over here. The slope therefore is 10.4 divided by 0.62, which is again 16.8 kilometers per hour. So this is the same answer we got when we used the formula directly. Here we got the answer by the graphical method, but earlier we had used the formula and we got the same answer. So this is how we can use the position time graph to calculate the average velocity. So this completes the part C of the problem. So part A, part B and part C are done. Let's move on. In part D, we have to calculate the average speed for the entire journey. The total distance, first driving and then walking to the petrol station and then walking back from the petrol station, would be 8.4 kilometers plus 2 kilometers and again plus 2 kilometers. The last plus 2 is because we are also considering the walking back distance. So this is nothing but 12.4 kilometers. The total time interval is 0.12 hours plus 0.50 hours plus 0.75 hours. This is again 1.37 hours. So the average speed SAVG is 12.4 divided by 1.37, right? The total distance divided by the total time interval. Now this is equal to 9.1 kilometers per hour. So this was the most easiest part of the calculation. You just have to you just had to divide the total distance by the total time interval. So that's it. All 4 parts of the question have been answered. So I think this is a good time to stop. In the next episode, we will deal with ideas such as instantaneous velocity and acceleration. So in the meantime, keep practicing, and if you have any doubt, the comment section is always open. Thank you for watching the video.